here's an example of a place where we would use the remainder theorem, and it's not going to be m is 1 because it's a sine or cosine. So here we have a Taylor polynomial which estimates the value of e to the x. We're all agreed there, right?
Yes.
And this is a third order polynomial.
Yes.
Taylor
We might summarize this polynomial as P3. So far so good?
Yes.
All right. Now,
Wait, the error is what letter are you using?
okay, we say that the error
is R3.
R.
is the absolute value of R3,
That's right. Oh wait, it's
which must be less than
M
magical value m
times the absolute value
times x minus a to the
+1 and +1.
n plus 1. In this case, it'll be 4.
I think it's the absolute value of x minus a.
Yeah, it's absolute. We should get nothing except positive values out of this. All right? And then divided by 4 factorial. Now, let's talk about the value that m would take on. It is
The maximum value?
the maximum value of the fourth derivative of our function.
Yes.
Well, if f of x is e to the x,
And then f
prime of x is
e to the x.
e to the x, and then f double prime is,
E to the x.
Just skip.
okay, no.
Yeah.
So the fourth derivative is e to the x. Now,
Yes.
I'm going to ask this question. For what value
Has to be
on the
between x and a.
interval from negative 0.1 to positive 0.1 does this function take on its highest
Positive point one.
It has to be +1.
it has, well,
Positive point one. Positive point one.
positive 0.1. So if we wanted to find out what m should be, we're going to say it's going to be the value of e to the 0.1.
Okay.
Now I'm just going to write down as e to the 0.1.
Okay.
What value are we going to choose for x and a? Well, we don't have a choice for a. It is 0 because this series is
Centered at zero.
centered at 0. So we are going to use 0.1 to the
Fourth.
fourth power divided by
4 factorial.
4 factorial. Or we're going to say the error has to be less than,
1.11. I don't know.
we're going to just go, did you put it in the calculator already?
Well, I put
E to the first times 0.1 to the fourth divided by 24.
.001.
Oh, sorry, e to the 0.1 times 0.1 to the fourth divided by 24, and you get
.001.
0.00111.
1. 78849.
7, 8, whatever. Okay, now,
But it has to be 7
now, does reality match that statement? How can we find out whether reality matches that? We say that the error is no bigger than that. Well, let's graph it. All right. So let me bring this over here. Okay. Oops.
Man, I did it totally
Yeah,
wrong.
Mr. Federico messed up.
I did it wrong.
I didn't do
It's
that.
point
Yeah, I was
zero
gonna say
zero
that.
zero zero
Wait,
zero
wait.
five.
Okay. Let me get it. E
4.604
to the power of 1
Yeah.
0.1
-6.
times 0.1 to the fourth power,
Did you? I did it wrong.
and then take all of that and divide it by 24.
It's the same thing.
Is that?
I accidentally put a 4. I put .4 to the
I have to
fourth.
get them out there when I go to college.
Are we okay now?
We.
Now, again, my question is, does reality match this error?
Let's find out.
Okay.
Well,
So let me map.
Let me graph.
Let me map the error, which would be math, absolute value of e to the x, that's natural log, second e to the x, there we go, e to the x minus, and then what did we have? We had the first,
Absolute value.
4.
we had the
Four.
first 4 terms, which means we had the c to the 0th term through the 3rd term, or through the 0th term to the
Third.
Third
if you
order,
wanna
yeah.
the
count-
3rd order term.
Yeah.
Yeah.
Okay,
So then
which is 1 plus x
x
plus x
plus x
squared divided by 2.
2
Oops, I didn't get a divide by sign. Divided by 2
plus
plus x cubed
x cubed.
divided by 6. Is that right? I got absolute value signs in there. I'm only interested in what's happening between negative 0.1 and positive 0.1. Is that right?
Yeah.
Yeah.
All right. I am going to zoom
0.
fit, which is zoom 0. Okay, there's my error curve. This is measuring the distance between the real function and the polynomial estimator. It looks like it's maybe a little higher on the 0.1 side. So let's do a second calc value at 0.1. And we get 4.25 e to the negative 6th.
So this is,
How does that compare to what we said the error would be?
That's not the
Said
right
that
value though.
that's not the right value.
We calculated
Oh,
it, but you
okay.
didn't write it. It's
Hold on. It was 4.
6049 times 10 to the negative 6.
Let me get that value of y.
I'm putting the same thing you guys got. My graph looks.
So here's the error that was on the graph. Here's the 4.6 times e to the negative 6 is the error that was calculated by hand. And here's the real error.
How do you know? Wait, what?
Wait,
Y?
can
You
show
just
what
put down
in
Y?
your y equals?
How'd you do that?
Sorry.
Okay, wait. I got 2 questions at the same time.
Sorry,
Who wants to yield?
Thomas first. Thomas first.
I'm yielding.
Okay, he's yielding.
Oh, sorry. Can you just show me really fast what you put in y equals?
What I put in y equals was the absolute value of e minus the polynomial estimator of e.
Oh, okay. So that's the
So
other way to find
it's
out.
f of x minus p sub 3.
So that's the other way to find out the value of error.
Mm-hmm.
Okay, we can do that graphically.
And then
on
you
a-
went
When occasion, yeah, when given the opportunity, yeah.
And then you hit zoom 0, and then I don't know how you got your.
How I got,
You changed the window.
I changed the window so that the width of the values of x that I was graphing were only from negative 0.1 to positive 0.1. And then when I did a zoom fit, it set the y values so it was appropriate. Okay, Ethan? You're not going to have a forehead. I don't know. All right? And then what did I do? I said second value, and I said give me the value of that error when x was 0.1. And now there's a y value there. And all I did was I went to the home screen and I asked, what's the y value? So here's the real error. Here is the estimated error. And all we're saying with this error estimation formula is that we're guaranteed that our estimated error is bigger than the real error
Yes,
because it's conservative.
it is.
Okay.
It's larger than the real error.
Now, it's really a small estimated error. All we're saying is that we're no worse than that.
Right.
So does it matter which way you do it, or you really prefer to do the one that's more correct?
Well, I mean, what's going to be expected? You're not expected as part of the AP exam to use your calculator to find errors.
Really?
You are expected. Now, there's only 4 things that you're required or mandated to be able to do on your calculator.
Okay.
Those 4 things are find a numeric derivative,
On a numeric.
find a numeric integral, find intersection of 2 curves on a graph,
Max and mins.
and to find a 0
Oh,
on a graph. Max and mins, you do not, if you were to use only the max and min functionality on your calculator to answer a max and min question, you will get 0 in a free response question.
Right, yeah, exactly.
It's not one of the four things.
So you can't use calculator?
No, we're using the calculator in this instance as a learning tool to say, look at this theorem that we put into place and see, yes, it does match.
Okay.
Oh. Wait,
Yeah.
so
We're being very frustrating
this
right
way
now,
you
aren't
have
we?
to use calculator to theorem? Because I don't know what E.1 is.
No, you just leave
No.
it.
We used,
No, no, no,
just
no.
leave it that
Okay,
way.
now, would you like the contradiction of what we just did is in order to find out how far we are from the E function, we use the E function. Yeah, that is really quite,
Elementary.
not elementary, contradictory. I'm going to try to estimate the value of rain that we're going to get today. And I'm going to do so by measuring the amount of rain that we got today. That's the contradiction of this process that we're doing.
Okay.
Now, could we be more conservative? Instead of using how many decimal places of E, could we have used, let me use a red pen here, could we have used 2.72, a larger value than E? Sure. And can we look up on some table of values using old school methodology what the 10th root of that is? Yeah, we could. We could have made our answer even more conservative and not gotten into this contradiction.
No, I'm just saying, why did you learn that theorem if you can't really?
Because you can, just with less precision.
So
Oh,
we're
I'm saying
allowed,
on a
we're
test.
allowed to leave it in that format on a free response question.
On the free response question, they will probably put this not in the calculator section.
Yeah, that's what, okay.
All
Sorry,
right.
that's what I'm asking.
All right? Now, the way they have asked these kinds of questions in the past is that instead of putting you in the position where you're trying to prove, or you're trying to say how aggressively I choose M, they may do things like, here's a table of values having to do with,
E to the
no, not e to the x. Here's a table of values having to do with some unknown function and the range of values that that function takes on in the first, the second, and the third
Oh, so you
derivative.
just take the.
So you may be pulling the M value out of a table of values, for example. Or, like sine and cosine, you may be using the value 1, like we've been showing.
Yeah.
Or they may hint at some other methodology.
But they don't mind us using it, even though it's kind of like contradictory.
I have
I'm
not.
just asking the same thing.
No, I understand what you're saying, and my response is, the people who write the tests are going to do so in such a way that you don't enter that contradiction. They have the ability, and you'll see this more once we actually start doing sample free response questions from this section. Okay, so it will be made clear.
Okay.
It will be made more clear when we get to start doing those problems. All right. But yes, I see the inherent contradiction too. All right. I think that's a long enough recording for this.
Yeah.
Oh my
So this
God.
was a 33.
Yeah, that was
All right.
33.
All right.
Sorry.
That's all right.
Kind of went
Future
over.
students won't mind.
Tell that to their ears. Sorry about